I want you to imagine, just for a second, taking one of those panoramic photos on your smartphone. You know exactly the kind I mean.
Oh, yeah, where you're panning across a beautiful landscape or maybe a busy intersection.
Right, exactly.
Yeah.
And right in the middle of your shot, a car drives through the frame.
Oh, I hate when that happens.
Yeah. And when you pull up the final photo, the software has just completely glitched out. The car is melted in half, stretched like silly putty across the screen, just sort of blending into the pavement.
Right. It's a funny little quirk of technology.
It is. But now I want you to take that exact same blurry, confused, melted output. And instead of a car on a street, imagine it is a critical pressure valve in an oil refinery.
Wow, okay. That shifts things.
Or like a massive cooling pump in a high-voltage manufacturing plant. Suddenly that digital hallucination isn't so funny anymore, you know.
Yeah.
In an industrial setting, it's a catastrophic liability.
I mean, it is the absolute definition of a critical failure. And I think it perfectly frames the massive wall that the industrial tech world has been just slamming its head against.
Right.
Especially when it comes to artificial intelligence and spatial computing. The stakes are just way too high for approximations.
So true. And welcome to today's deep dive. We have a really fascinating stack of sources on the table today, looking specifically at a major announcement from July 7, 2026.
Yeah, this is a big one.
We've got a press release from a company called EON AI Ventures, alongside some honestly really dense technical excerpts from their latest white paper.
The one titled EON Universal, Recognition to Twin.
That's the one. And our mission for this deep dive is to explore exactly how EON AI Ventures has cracked one of the most notoriously difficult problems in the industrial sector.
Right, turning 2D photos into fully accurate, operable 3D twins.
Exactly. And doing it in minutes without the AI spitting out that blurry, melted mess we just talked about.
Which is huge, but right out of the gate, I feel like we need to address the elephant in the room.
Go for it.
Because someone listening right now is inevitably thinking, wait, AI generates 3D images all the time. We've had neural radiance fields, standard photogrammetry. We've had this tech for a while. So why is this such a big deal for a power plant?
And that assumption right there is exactly what has been leading the industry astray. There's this widespread and frankly false belief that generic modern AI can just seamlessly translate photos into a functional 3D environment.
But the EON white paper points out, with pretty brutal clarity, that this assumption completely breaks down in practice.
Yeah, especially when applied to high-stakes industrial environments. The sources are actually pretty unsparing about what happens when you try to use off-the-shelf image to 3D generators for this stuff.
Right. If you take a handful of photos of a facility and feed them into a generic model, you don't get a usable facility out the other end.
Not at all. You get what the paper calls a single, blurry, unlabeled mesh.
Because generic AI is fundamentally semantically blind.
Semantically blind. I like that phrase.
Yeah, I mean, it is essentially just looking at pixels, identifying contrasting light and shadow, and trying to guess the surface geometry. It's just creating a continuous skin.
Right. It has absolutely no semantic understanding of what it is actually looking at.
Exactly. To standard photogrammetry or a basic NERF, a highly pressurized steam valve and a fire extinguisher are just blobs of color and shape occupying space. It cannot tell a pump from a pipe.
It has literally no idea what it's looking at. And even worse, it has no native concept of scale.
None.
Like, it doesn't know if the pipe it just modeled is 2 inches wide or 2 feet wide.
Yeah.
And because it's just a single continuous mesh skin, it doesn't know what connects to what.
It's basically a dead object.
Yeah. You can't click on a valve and see where the fluid goes because to the AI, the valve and the wall behind it are literally the same object.
Which completely defeats the purpose of an industrial digital twin. I mean, a digital twin isn't just supposed to be a pretty 3D fly-through for a corporate presentation, you know.
Right? It's supposed to be a functional replica.
Exactly, an operational replica of a physical space. If an engineer selects a valve in a true digital twin, the system needs to know its exact specifications, what pipe it routes to, the cascading effects of shutting it off.
And a generic AI mesh simply cannot do that. Reading through the white paper actually made me think of a Hollywood movie set facade.
Oh, that's a great analogy.
Right. You walk down the street on a studio lot and you see this beautiful, incredibly detailed saloon or a bank. It looks perfectly real from the street.
But the second you try to turn the doorknob?
Or go inside and turn on the faucet, yeah, you realize it's just a flat piece of painted wood held up by 2x4s. There was no plumbing behind it.
No electricity, nothing. It's just a visual illusion.
Exactly. In fact, there was a quote right here in the source that perfectly captures this. They say of the generic AI output, it looks like a model. It is not a twin.
The Hollywood facade is really the perfect way to visualize the problem. And because that facade is utterly useless for actual engineering or high-stakes training, the industry has historically been forced to rely on a much more painful method.
Oh yeah, the brute force method.
Right, until this EON Universal announcement, getting a true, operable digital twin required what is known as a manual scan-to-model workflow.
And the sources note that this old way was just a massive logistical headache. We are talking about a process that typically took around 12 person days of grueling manual labor just to complete a single environment.
12 days. Let's break down why it took that long, because it really highlights the friction in the industry.
Please do.
So first, you'd have to send in teams with expensive LiDAR equipment. They laser scan the facility, which generates a massive point cloud.
Literally millions of data points. Right?
Millions.
There.
Then human engineers have to sit at CAD workstations, manually clean up the noise in that point cloud, manually identify and label every single pump,
Oh man, that sounds awful.
and then measure every physical distance and digitally redraw the cylinders of the pipes to connect everything together logically.
It's digital manual labor. It took almost 2 weeks, and according to the press release, it still routinely yielded mediocre results.
Because human error inevitably creeps into a process that tedious.
Right, you click a few millimeters off on a point cloud, and suddenly your digital twin has a pipe intersecting a solid concrete wall.
Exactly. And what's really interesting in the source material is the sheer honesty from the company itself about this whole struggle.
Oh yeah, Dan Lajursky.
Yeah, the founder of EON Reality. He goes on the record in the press release admitting they tried to do it the easy way first.
I have his quote right here. He said, "We tried the obvious thing first, a few pictures into an image to 3D tool, and the results were poor. Bad resolution, no real distances, no intelligent stitching, and a mesh that didn't know what anything was."
I really appreciate that transparency. They realized that throwing generic AI at a highly specific engineering problem just creates a faster movie set facade.
It doesn't build the plumbing.
Right, which is the perfect pivot to how EON Universal actually solved this end-to-end. They had to fundamentally abandon that architectural approach.
And they call their new framework the recognition to twin architecture.
Yes. This is where we move from unstructured data to structured data.
Yeah.
Because they realize that photos alone simply do not contain enough structural logic to build a twin.
You cannot extract operational reality purely from visual pixels.
Exactly. So instead of asking the AI to guess the plumbing, they feed it the actual engineering truth. They take all the available field photos and they fuse them with the facility's master engineering drawing.
Specifically the P&ID.
The piping and instrumentation diagram, yes.
For anyone who has ever looked at one, it's essentially the facility's DNA. It is the master schematic that says exactly how every single pump, valve, tank, and pipe is logically supposed to connect to each other.
It's the blueprint.
But here is my question. How does an AI look at a 2D line drawing, which is essentially a flowchart, and combine that with a bunch of random smartphone photos to build a 3D world?
That bridging of 2D logic and 3D spatial data is the true breakthrough here. The AI approaches it through a form of topological mapping.
Okay, walk me through that.
Think of the P&ID as a graph. Node A connects to node B via a specific pathway. The system first ingests all the available ordinary photos of the facility.
Just standard smartphone photos.
Yep.
It uses advanced computer vision to find the overlapping features in those photos and stitches them together to create what they call a coherent 3D skeleton.
So the photos provide the spatial reality of the room, like where things are physically located in three-dimensional space.
Exactly.
But relying just on photos, I feel like that's trying to build a 10,000-piece jigsaw puzzle by only looking at the shapes of the cardboard pieces. You might fit a few together by guessing based on edges, but you have no idea what the picture is.
That's a brilliant way to put it, honestly.
Yeah.
Building the 3D skeleton is just assembling the blank cardboard pieces.
Right.
But feeding the AI the P&ID blueprint is like finally handing it the picture on the front of the puzzle box.
Right.
Suddenly it has the logical map.
Oh, wow. So it knows that between the large cylindrical object in the corner and the small valve in the center, there must be a specific type of connection.
Precisely. And this leads to step 2, which is where the recognition part of the architecture kicks in.
Yeah.
The AI looks at that blank 3D skeleton and recognizes the components. But instead of trying to artificially generate a 3D model of a pump from scratch, which leads to that melted car hallucination we talked about earlier, it does something much smarter.
It goes to the EON Universal Component Library. This is the critical difference between generation and retrieving.
Okay, explain that difference.
Sure, so it identifies a component in the photo. Let's say it spots the visual markers of a centrifugal pump. The AI cross-references that with the P&ID to confirm, yes, there should be a centrifugal pump here.
Makes sense.
Then, instead of drawing one, it reaches into its vast, pre-existing digital library of perfect, clean, correctly scaled 3D CAD models. It pulls the exact right component out and anchors it to the 3D skeleton.
Okay, wait, I need to stop you there
Oh.
because I have to push back on this on behalf of our listeners.
Go for it.
If the AI is just pulling a pristine, perfect pump from a digital library and snapping it into place, isn't that a huge problem for accuracy?
How do you mean?
Well, real factories are incredibly messy. The pump on floor 3 is 10 years old, it's covered in grease, it's been modified, and the pipes connecting to it might sag a little bit.
Sure, real-world wear and tear.
Yeah. So if the AI is just inserting a perfect library model, aren't we losing the actual physical reality of the floor? Doesn't swapping in a pristine asset destroy the accuracy?
That is a fantastic challenge, and it cuts right to why the underlying 3D skeleton is so vital. The AI isn't just rigidly dropping a block into a virtual room.
It's not.
No. The library component provides the semantic truth, the exact dimensions, the connection points, the operational parameters. But the system uses the visual data from the photos to scale, orient, and route that component based on the ground truth dimensions of the room.
So it bends to the reality of the photos while maintaining the engineering integrity of the library model.
Exactly. It dynamically fits the perfect logic into the imperfect physical space.
Okay, that makes a lot more sense.
Which brings us to step 3, routing. Once those verified library components are anchored in their real-world spatial positions, the system uses the P&ID to automatically route the correct piping between them.
It draws the connections perfectly, exactly as dictated by the engineering drawing, navigating the 3D space to make it happen.
It is wild to think about. Simplicity is clearly the core value proposition here.
Seriously, no laser scanner, no specialist crew, just the P&ID and ordinary unsorted smartphone photos.
Taking the visual spatial data from unstructured photos and binding it to the logical engineering data of a P&ID using a recognized component library.
The source actually notes that this underlying method is currently the subject of a pending patent application.
And rightfully so, because solving the semantic segmentation problem without requiring massive compute power or manual tagging is really the holy grail for industrial spatial computing.
But that speed and simplicity raise a massive flag for me regarding trust.
Trust is huge.
Right, because if we are talking about an oil refinery or a heavy manufacturing floor, an AI hallucination isn't just an inconvenience, it's a massive liability.
Oh, absolutely.
If the system misidentifies a high-pressure valve or routes a pipe incorrectly in the twin, and a worker relies on that for a maintenance procedure, someone could get seriously hurt.
It's a life or death scenario.
Yeah. So if they're completely removing the human CAD engineer from the loop, how do they ensure this digital twin isn't just fast, but mathematically safe to use?
Trust is the currency of industrial engineering. If the facility managers don't trust the twin, the entire platform is dead on arrival. EON AI Ventures knows this.
So how do they handle it?
Well, the white paper spends significant time detailing their rigorous validation mechanism. It operates on 2 distinct layers.
Okay, layer 1.
First, every single value and component assigned by the system carries a confidence score. The AI doesn't just act. It constantly evaluates its own statistical certainty based on the visual and logical data overlap.
So it's flagging its own work. It's saying, I am 99.9% sure this is a pressure gauge based on the library and the P&ID.
Right. And if it's only, say, 60% sure, it flags it for human review rather than just blindly guessing.
It brings a human in only for the exceptions, not the rule. I like that.
Precisely. But the second layer of validation is even more impressive.
Oh.
Once the finished 3D twin is assembled with all the library components anchored and the piping routed, the system takes that newly generated 3D world and independently validates it against the original source photographs.
Wait, It essentially reverse engineers its own work to double-check itself.
Yes. It looks at the 3D model it just built, projects it back into 2D space, and compares it pixel by pixel with the original photos.
That is wild.
It ensures that the components aren't just the correct models, but that they are placed at the exact real ground truth positions and scaled to the precise real-world dimensions.
So if there's a spatial deviation between the twin and the photograph, the system catches it immediately.
Exactly, which totally shifts the paradigm of how we think about the time investment here.
Oh, for sure. When you combine that level of guaranteed self-correcting accuracy with the automated assembly process, the numbers they are quoting are staggering.
They really are. The press release explicitly states that EON Universal turns what used to be a 12-day manual job into a task that can be completed during a, quote, coffee break.
From 12 days of tedious manual laser scanning and CAD modeling to a single coffee break, that's just hard to wrap your head around.
And you don't end up with a messy point cloud. You end up with a vastly superior, fully operable, semantically rich result.
So we need to contextualize this for you, the listener. Why does a perfect, instantly generated 3D replica of a factory matter on a macro level?
That's the big question.
The sources explain that this specific technology, EON Universal, is actually a value add built on top of a larger, pre-existing platform called EON Genesis.
Right, and Genesis is entirely focused on something called work intelligence.
Work intelligence. It's a fascinating concept. The white paper defines it as the captured, verified, and compounding knowledge of how expert work is actually done in the field.
Because industrial enterprises have incredible veteran experts. But capturing their procedural knowledge, the muscle memory of how they navigate a facility so it can be reliably taught to new workers is incredibly difficult.
And reading between the lines here, the biggest hurdle for these enterprises trying to use EON Genesis wasn't the software itself. It was simply building the 3D environments to train their people in.
It was a massive bottleneck. You can't deploy spatial training if it takes 2 weeks to build a single room.
Exactly. And EON Universal completely removes that friction. Now, because the twin is perfectly accurate and generated in minutes, enterprises can immediately deploy it for incredibly high-stakes tasks.
The source specifically highlights employee training, facility maintenance, and critical safety protocols like lockout and tagout.
Lockout tagout is perhaps the ultimate test of a digital twin's fidelity.
Oh, absolutely. For an industrial tech audience, you already know how unforgiving standard lockout tagout protocols are.
You cannot afford a millimeter of ambiguity when isolating a high-pressure system or a high-voltage grid.
No. If you miss one valve in the sequence, the machine remains energized, and the consequences are fatal.
In the past, workers had to learn that precise sequence by reading a dusty binder or trying to shadow someone on a live, dangerous factory floor where mistakes just aren't an option.
But now they can pull up a perfectly accurate, validated 3D twin of that exact facility on their device.
Right. By tying the twin directly to the P&ID, workers aren't just looking at a spatial map. They're running through the exact logical sequence of isolation before they ever step onto the floor.
Because the AI knows what the valves do. It knows the sequence. Because the engineering blueprint programmed the plumbing of the twin.
It encodes expert procedures into AI-guided simulations and delivers them to any worker securely on any device.
And what's crucial to understand about this announcement is the pedigree behind it. It's really important to ground this innovation in its historical context.
Yeah, EON AI Ventures isn't some overnight Silicon Valley startup that just discovered industrial AI last week.
The press release makes a very specific point to highlight their background. This new intelligence flywheel platform, which includes Genesis, Field IQ, and Assess IQ, is built on a 25-year foundation.
25 years of deploying immersive learning technology across more than 80 countries.
And that quarter century of experience is exactly why they didn't settle for the generic AI movie set facade. They've been in the trenches of immersive industrial training long enough to know what actually works in the field.
They knew that an unlabeled, blurry mesh was a dead end because you can't train a mechanic on a map.
Exactly. They had the deep domain expertise to realize that bridging the unstructured visual data of field photos with the structured logical data of a P&ID was the only mathematical way to achieve the ground truth accuracy the industry requires.
It is such a brilliant leap in logic. So let's take a step back and look at the whole picture we've painted today.
Let's do it.
We started by looking at an industry that was trying to force generic image to 3D AI to do a job it fundamentally wasn't built for.
Resulting in those blurry, useless, melted meshes that couldn't tell a high-pressure pump from a fire extinguisher.
Right, a technological gap that forced engineers to rely on a manual scan-to-model process that burned through nearly 2 weeks of labor just to get a single static environment.
And now, thanks to this July 2026 breakthrough with EON Universal, that bottleneck is effectively shattered.
By intelligently stitching together a 3D spatial skeleton from ordinary smartphone photos, matching it to a vast library of clean components, and automatically routing the logic through the facility's actual P&ID blueprint.
They've solved the semantic puzzle.
They really have. They are generating fully connected, independently validated, and completely operable 3D industrial twins in the time it takes to drink a cup of coffee.
No multi-thousand-dollar laser scanners, no specialized CAD crews.
Just verified work intelligence ready to be deployed into the highest stakes environments on Earth. Which leaves us with a truly fascinating implication to consider as we wrap up.
Yet think about this. If complex, highly dangerous physical infrastructure, like a chemical plant, an offshore rig, or a power grid, can be perfectly digitized, independently validated against reality, and made fully operable in mere minutes.
How long until the very concept of on-the-job training happens entirely before a worker ever sets foot on the actual physical site?
Exactly. If you can run every maintenance simulation, every lockout, tagout procedure, and rigorously verify human competency in a perfect digital twin, what happens to our traditional idea of the workplace?
When the digital twin is just as functional, fully logically connected, and infinitely safer than the real thing, the boundary between the digital workspace and the physical factory floor essentially disappears.
That is a staggering paradigm shift. The idea that a technician could master the physical quirks of a specific facility from 1,000 miles away, it completely redefines industrial readiness.
We are moving from a world where technology gives us funny, melted cars in our panoramic photos to a world where it perfectly maps and understands the most complex engineering on Earth right from our pockets.
That is incredibly powerful.
It really is. Well, that is all the time we have for today's deep dive into EON AI Ventures and the reality of the operable digital twin. Keep your eyes on those blueprints, and we will catch you next time.